Hi all, welcome to AKS Math Academy. So today we are going to see class 12 exercise 5.1 of continuity and differentiation, first question. So let's begin. So for every questions of this exercise, there's only one particular theorem to be remembered, which we have already discussed in the previous class. So what is that theorem? A theorem to check whether the function is continuous or not, or to prove whether the function is continuous. Every questions in this particular exercise is based on that type of questions. So what's the theorem? Anybody remembered? So the theorem is limit x tends to c, f of x equal to f of c. C is a point which determines whether the equation is continuous or not. So, and f of c, we'll substitute the value of c in the equation, for the function. Okay. Now I'll read the question, first question for you. Prove that the function f of x equal to 5x minus 3 is continuous at points x equal to 0, x equal to minus 3 and x equal to 5. So for each particular three cases, we should prove that our equation is continuous. So how do we prove? We'll prove that in left hand side and right hand side are equal. So let's begin. First case is that at x equal to 0. Here x equal to 0. X equal to 0 means c is 0, okay? Because that point, we should check at that particular point whether the equation is continuous. So the point that determines whether the equation is continuous is known as c. Okay, now for this, we'll write left hand side as limit x tends to c value is 0, I have already said, and f of x value is 5x minus 3. Now, how do we open this up? We have already learned in our class 11 limits and derivatives. In place of x, we will just substitute 0 because there is no, we don't have any condition for x values or something. For mod operator, there will be some particular conditions, but here it's not a mod operator or nothing, it's just a particular algebraic expression. So we will just substitute the value of x. X is 0, x tends to 0 means x value can approaches to 0. So 5 into 0 minus 3. Answer will be minus 3. I'll write minus 3 here. So limit x tends to 0, f of x, 5x minus 3 will be equal to minus 3. Answer is minus 3. Now, this is left hand side. This side we got answer as minus 3. Now f of c. What is f of c? F of c is f of 0, right? F of 0 means, let's just substitute x value 0 in this equation. So you'll get 5 into 0 minus 3 equal to minus 3 itself. So this implies limit x tends to c, f of x equal to f of c. Hence proved, and we will say that equation is continuous at point x equal to 0. First case over. We have remaining two more cases. What is that? At x equal to minus 3. No, wait. For x equal to minus 3. Similarly, we will do this, where the point of c changes. That's it. Rest all remains the same. X tends to minus 3. F of 5x minus 3 and 5 into minus 3 which gives 5 into minus 3 is minus 15 and minus 3 gives minus 18. So left hand side gives minus 18 and f of c means f of minus 3. We'll just substitute minus 3 as x in this equation. So we'll get the same itself, 5 into minus 3 which is minus 18. So similarly we'll write therefore limit x tends to c, f of x equal to f of c. Hence what? F of x is continuous at x equal to minus 3. It's not discontinuous. Suppose we will get some value here and that will be not same as what we get here. Then we can say that f of x is not continuous at that particular point. But here we got everything as same. We'll be dealing with that type of questions in the future questions. So at that time we will get point of discontinuity. Here everything is continuous. No, we have to prove they are continuous, right? So point x equal to 0 is continuous, x equal to minus 3 is continuous, and at last we have x equal to 5. at x equal to 5. So yes, what is left hand side? Limit x tends to 5, f of x means I'll just substitute those values, 5x minus 3, which gives 5 into 5 minus 3, 25 minus 3 gives what? 22. Now what is f of c? F of c is f of 5, which again gives the same, 5 into 5 minus 3, which is equal to 22. This implies limit x tends to c, f of x equal to f of c. Hence proved, f of x is continuous at x equal to 0, x equal to minus 3, x equal to 5, because it satisfies this particular condition. So it's very easy question, right? We'll be dealing with similar questions in the upcoming classes. Thank you.